So thank you so much for showing up at 8 in the morning. And it means more because you are all in Vegas, right? So you must have been partying. So what are we going to talk about, right? So agentic shift in software development lifecycle. So from the time you have been attending Google Cloud Next for the last 2 days, you must have heard so much about agents, right? And AI. It's all about AI and agents, right? Everywhere. So we are going to talk about the adoption trends in AI. How do you manage multiple agents together when they work in parallel? And more importantly, how do you take the code that you have built using AI to production, right? And then we will wrap it up with a special session about the success of AI initiatives in software development lifecycle at Wipro. My name is Alok Srivastava. I'm a product manager in Google Cloud. I will be joined by Rakesh Dhoopar, who is the director of outbound product management in Google. And then we have Sachin Chandra, global head of Google partnership at Wipro. All right, so let me ask with a raise of hands, because we don't have a poll here. How many of you are using AI actively in your work? It can be software development or something else. Right? Pretty much everyone, right? And that's exactly what we have seen here, right? So DORA, DevOps Research Assessment, they run an yearly survey, right? So they talk to thousands of developers across the globe, not just within Google, but across the globe, across different companies. And they talk to the developers in a qualitative manner, which involves hundreds of hours of qualitative data. So we have seen that almost 90% of the people are using AI at work, right? And where is AI getting adopted? So as you can see on this slide, for writing new code, almost 70% of developers, of the employees that were surveyed, are using AI, right? So which is what you call as greenfield development, right? We'll talk about both greenfield and brownfield in our session as we go forward, right? So one of the key findings of DORA is that the primary role of AI in software development is that of an amplifier, right? So what does amplifier do? It boosts the signal, right? As in musical devices, electronic devices. So in case of AI, if your context is clean and if it is reasonable enough, then the same goodness will flow in, will spread into your entire workspace or code space. But if my intent and my context is lacking somewhere, then the same mess will flow in or spread into my entire workspace or code space. Yep. So how many of you read Sundar Pichai's blog yesterday, right? So we have been tracking the adoption of AI for writing new code within Google, right, from the last 2 years. And this number was a little more than 12 months ago. The number was around 25%, and then it was around 54% last fall. And now we are at 75%, where all the new code at Google is getting generated with AI. Yeah, and why is it happening? Why it didn't happen earlier, right? Because 1.5, 2 years back, if you recall, with AI, things are moving so fast, right? So 1.5, 2 years appears like a long time, but we were in a stage where we were doing retrieving, right? And from retrieving, now we have evolved to reasoning. We have evolved from prompt and response to plan and execute. And with agents coming in, you are not just typing a prompt and getting a response and then doing an iterative prompting, right? With agents coming into a picture, you want to build, let's say, a banking web app, right? Or you want to modernize your code. You provide a prompt, you get a response which asks you what kind of programming language you want to use, what kind of layout, right? Are these requirements looking okay to you? And that's what we call as humans in the loop, right? We are not yet there in terms of think about a completely FSD or a fully self-driving vehicle. So we are not yet there, right? But in some form, we are there. For example, if you look at the agentic code review agents that are available, you go to GitHub, download the code review agent, which is provided by Gemini Code Assist, and then the moment you create your pull request, the agent kicks in, right? even then in some forms, you will still need human in the loop. Yep. So with so many agents everywhere, what is bound to happen? Some form of conflict, right? Some form of agents stepping into each other's territory. So what's the answer, right? So we will be talking about a very recent framework and a testbed orchestrator that is built by one of the Googler, right? So we'll get there. But before we go there, let's look at what kind of challenges we face when you have multi-agents in a system. First and foremost is the isolation and security. So I build an agent. It can be, let's say, a custom agent, and then there are some out-of-the-box agents provided by Google. They can be provided by somebody else. And then you have your own development, your own workspace, right? So the agents can go rogue and even end up doing something like RM minus RF, right? So that's the adverse kind of, or the most adverse situation that can happen. But the agents can also intermingle and create conflicting actions, right? And then so many agents, so many models. So there are specific agents which are tied to specific models, right? So they are hard-bound, and there is a tight coupling between the agents and models, right? So these are some of the challenges. So that's where we talk about the latest and greatest solution, which we call as Cyan, right? So this is open source testbed for orchestrating AI agents, right? How do we orchestrate it? We will see all of that in a demo, right? But at a higher level, or at a philosophical level, think about it as a hypervisor of agents, right? Hypervisor, we are all aware, Hyper-V, VMware, right? So there is a solution, and that hypervisor manages a fleet of virtual machines, under which you have different operating systems, different applications. Now think about Cyan as hypervisor of agents, which means that now you are managing a fleet of agents, right? And all these agents are running in isolated environment in the form of containers in a fully secure manner. So let's see Cyan in action. Can the backend team please help me switch to my local machine, because this is a demo and then I may want to skip to certain sections. Thank you. All right. Yeah. So this is my local environment. So I have configured Cyan already here. You can see that when I give the command Cyan, this beautiful ASCII characters, they appear, right, with the version and everything. So it is available on GitHub. You can go download, install, pretty easy, like maybe in 15 minutes you will be up and running. Yeah, so it describes what Cyan is: container-based orchestration tool for managing concurrent LLM agents. And then you are able to do parallel execution of multiple agents, right? So we were talking about the support of multiple LLMs, right? So let's look at how it looks. So I give this command, Cyan harness config. Yep. So you are seeing not just Google's Gemini products, right? You are not only seeing the Gemini models. So there is Claude, Codex, Open Code, right? And again, on the right-hand side, you see something called as image. So these are the container images that we will use when we try to actually build an agent using Cyan, right? But Cyan, I'll re-emphasize, this is not just about doing a coding task or software development task using AI, right? That you can do even without Cyan, right? So it's about creating a specific container where your agent is running in a secure manner, right? So let's see what happens next. So this is where we'll be giving this command. Yeah, so we are saying to create a Python script doing some Fibonacci work, but then we are also calling Gemini, and we are calling that specific container image that was mapped to Gemini when we listed all the models that are supported by Cyan. Yeah? So now what you see here is a tmux session, right? So for those of you who may not be aware, with tmux, so this is like when you are on your terminal, but you want to create another one, right? A sub-terminal within your terminal where specific processes or programs are running. That's what Cyan is doing here, right? So that there is no impact to your local terminal, right? We will also see that you can even detach the agent that I have spawned, right? Detach doesn't mean that it will stop and running, right? So it will continue to run, and then you can come back to your terminal and do your other work. Yeah, so this is interesting. When we see Git work tree list, right? So how many of you, like most of you are using Git if you are into software development. So I talked about isolation, right? And that's what I want to highlight here. Let me even increase the font a bit. Yeah, so you are seeing that I'm giving Git work tree list, and there is this directory from where I launched Cyan, right? But the agent which is running has created another path from where it is doing its work, right? We gave a prompt to create a script for printing the first 10 Fibonacci numbers, right? So, but it is not in my main. So which means that even if my agent goes rogue, or even if my agent does something unexpected, it will in no way impact the work that I am doing in my main directory. Yeah, let's move further. How many of you use products like Gemini CLI? A lot of you? Okay, it's pretty good. Yeah. So yeah, you can go to GitHub and just search for Cyan, and then you can deploy it on your local machine. You may need an environment like Docker, right? Even I had got Docker here on my environment. The reason why I'm not able to do a live demo because I got a notification from our security team saying that, hey, you cannot have Docker running because of certain conditions. So I had to uninstall it, and that's why you see a recorded demo. Now, what we are seeing here is, let me just proceed here. Yeah. So my agent was running, right? It is detached, and now when I'm doing a listing, as I talked about tmux, right? So I'm opening two different terminals, but you can do it on the same terminal also. So you are listing, and this is the .py file is exactly what we wanted it to create, right? At the end of the demo, we will see how good is that file, and based on that, we can accept it or reject it. So we are going to stop the demo agent, right? And then we will see what is the impact of stopping that demo agent, right? Are our directories there, right? Because when you do, let's say, some of you might have tried your hands with vibe coding, right? You do vibe coding, and then it is not ephemeral, right? Because it is there in your window, and then it goes away, right? So let's see the ephemerality or non-ephemerality of Cyan. So I have stopped the agent, and then I'll go back to the terminal, and we will see if the work that it has done is still showing up or not. Yeah, so I do a cat of that file. It is all there, while my agent has already stopped running. Okay. And from here on, the developer can accept the change, and you can even merge this, right? Not even, you will obviously merge the work that is done by the agent into your main branch. Can we please move back to the main slides? Yeah. All right, so I showed you a single agent, right? But the intent was to show how it can run in an isolated, secure environment without impacting your local workspace, right? But Cyan can be a test bed for multi-agent orchestration scenarios. So without getting into all the colors that you are seeing here, right? So what it is depicting that a single agent can spawn into multiple agents, right? Or multiple agents can converge into single agent, right? Or they can diverge into doing something, right? So every agent can have a sub-agent, and then it can have its own task, right? But irrespective of the scenario, irrespective of the number of agents, the way they are spawning, irrespective of the model, you will be able to orchestrate all of them using Cyan. Yeah, so some of the benefits and key features which were already very obvious when we were doing the demo, but I'll summarize it here. So you are able to run multiple agents in parallel, independent of each other. That happens with the help of the container technology, right? And something very important I want to call out again, that this is harness agnostic. So it is an open source framework, right? You want to give it a try, again, go to GitHub, get Cyan, get it up and running in 15 minutes, and it is open source, right? So it is publicly available for adoption, and it's based on the community-driven contribution, right? So I'll call Rakesh on the stage to talk about all the work that agents do, right? How do you take them into production? Thank you, Rakesh.
Thank you, Alok. Thank you, Alok. So how many of you here write code just to leave it on your desktop and never push it into production? That's a rhetorical question. Okay. I did not expect that answer. Most of the work that people are doing is to solve a problem. You write code, you want to push it into production, whether it's for your own individual use or whether it's for your enterprise or business or whatever. And like Alok was talking about, there's multiple ways to use agents to write code, whether it's through the CLI, where you're interacting with it, or it's through orchestrating multiple agents. The net effect of all of these things is that the velocity of developing code has gone way up. The productivity of developers has gone way up. But at the same time, the velocity is impacted by how the code actually makes it to production. And if there are bottlenecks in that rest of the pipeline, then what's the point of writing all of this code if it cannot make it to production? So what I will talk about is like how we are helping developers to actually make sure that the overall velocity of the entire pipeline is maintained as more and more code is getting written. Now, before I jump into that, one of the fact is that we're talking about developer productivity, but the amount of time developers spend writing and authoring code is anywhere between 16 and 25%. Different research studies have shown different amounts of time developers will spend writing code. So while it is important to improve that productivity, it is equally important to focus on the rest of the SDLC, which will include testing, documentation, pushing it into production, operating it, troubleshooting problems, and then optimizing it overall, the entire cycle of authoring and developing code. So that's what I will focus on. So if you look at this particular slide, there will be a pop quiz at the end to find out what all agents we actually have. Don't worry about the details of every slide. The point of the slide basically is that in addition to providing agents that help you author code, we're also providing agents that help you test code. Alok briefly touched upon it. We're also providing agents that help you with code reviews, right? Once you've checked in your code, you want code review agents to automatically kick in and do some testing. And we're not saying that all of this is so automated that the developer is completely removed from the pipeline. Even at Google, when the code is authored by AI, there is still a lot of developer checking and code reviews done by humans to make sure that things are moving on the right track. But we are building and providing agents for testing, for documentation, for pushing these things into production, for troubleshooting problems, and optimizing the cost of what you're deploying into these environments. So that's what I will focus on for the rest of the 4 or 5 slides that I have. So let's jump into the first agent. the design agent. Now, as developers build their code and they want to certainly first test something on their local environment, and that's fine. But before it gets into the pipeline to go into production, you want to test it in the cloud, right? Which actually invokes other services, it invokes data access and things like that. But how do you get access to an environment which is in the cloud? Well, many times people will file a ticket, somebody will provision some resources for you. Or if you have platform engineering teams, they may have already built some environments for you where you can go and test. Now, with the design agent, we help automate a lot of that. So with the design agent, a platform engineer can start off with a template that either we provide out of the box or you create on your own. And the platform engineer or the developer interacts with the design agent, again, as you can imagine, using natural language. While what this UI is showing, you do have a graphical canvas to see what your design looks like, but the authoring of the template, the modification of the template, the codification of your policies into the template can all be done using natural language. And through these policies, you can specify things like what configurations can the person who's instantiating the template make changes to. You can specify security policies. You can specify scaling policies, like how much do I allow somebody to scale this environment. So you can specify a lot of policies. And once you have these templates created, you can make it ready for the developers to use these templates, instantiate them, and do their testing. Now, when the template is instantiated, we do pre-flight checks. And these pre-flight checks will make sure that any of the policies that you've specified as a part of the template are actually invoked before the template is instantiated. Now, we provide many out-of-the-box templates for building a web application, for building an application that will access data, et cetera, et cetera. And these templates are based on best practices that we have built internally or working with our customers. Now, what we are also working on is an out-of-the-box template for agent platform. So yesterday, if those of you who attended Thomas's keynote, he talked a lot about the Gemini Enterprise Agent Platform. As you build agents and deploy them to the Gemini Enterprise Agent Platform, which sounds like a mouthful right now, you may need services like an agent registry, where you will publish your agents. You may need agent gateways that will be monitoring the traffic and enforcing policies. You may need model armor to check prompts. You may need an agent identity system that will give credentials to these agents to operate. Now, obviously, expecting anybody in your company, whether it's a developer or even a builder, right, people who are using these tools to build new applications, to go and provision all of these services is expecting a lot. So by providing an out-of-the-box template for the agent platform, literally somebody can go and instantiate all of these services and start using those. Now, a lot of conversation we always have is about greenfield environments, where you're building something brand new. But as you all know, in the enterprise, there are a few greenfield environments. 90% of your environments are probably brownfield environments. And you may have already built Terraform to work with your existing systems. What we are also announcing this week here is that if you have this Terraform that can actually be imported, and the design agent and the application design center, which is the canvas on top of it, will understand those and incorporate them into the templates and designs that you create using this agent. The second agent is what we call the investigate agents. Now, again, this is a rhetorical question, but I won't be surprised with the answer. How many of you build systems that never have any problems and you never have to troubleshoot anything? Okay, there's one person. Two. Awesome. I would like to talk to you guys after the session. That would be an interesting conversation. But as you deploy applications or agents, they will invariably have issues and problems. A lot of that troubleshooting is very manual, very tedious. Welcome to the war room kind of situation. Now, the investigate agents help you, again, use natural language to diagnose these problems. How do they actually work? So they use the Gemini reasoning models and they will analyze and evaluate your telemetry signals, logs, metrics, traces, to be able to come up with observations and hypotheses on what could potentially be going wrong. Those were the signals that we used to analyze and still analyze, but we have also now enriched them with additional signals, which includes the application topology. So if you have built an application that you've deployed to GCP, and you have populated the underlying platform component called App Hub, which is where the application model is stored, that information will be included as the agent analyzes the other signals. What will also be included are things like metric anomalies. And what you can include, and that's something you have to actively do, is runbooks that you may have in your environment, because those are the things you sometimes use to troubleshoot problems. So if you have runbooks that may be stored in Confluence or Jira, you can bring that information and specify that to the investigate agent so that it can use all of that information collectively and go analyze all of these signals. And it comes up with two things. There's observations. Observations, not technically anomalies, but observations are things that may be interesting, and these interesting things actually make the foundation for the hypotheses. And these are probabilistic systems, so hypotheses basically are some probability of this may have gone wrong. And based on those hypotheses, then you can explore further interactively to say what could potentially be the root cause. Now, one of the new things that we have announced again this week is moving these investigations from a reactive mode to a more proactive mode. So last week, if you went and used these capabilities, you had to actively launch an investigation. You could go to a log event that you identified, you could go to an alert that may be interesting, and launch an investigation. But we recently now we are introducing proactive investigations. So as you define your alerts in your systems, and when an alert is fired, an investigation can be launched automatically. So by the time a user is notified, they get the war room together, the analysis has already been done, and the hypothesis is shared with you in your console. Last but not least, until last week, when the hypothesis was supplied, and if next to each hypothesis there was a suggested remediation, which meant that if this hypothesis is the root cause, this is how you can go and remediate the problem. Those were suggestions. Like, we did not actually execute those suggestions. And those suggestions were also in terms of G-Cloud commands, but they were templatized, meaning you still had to fill in the information on what's your project ID, what's the resource ID, etc. Now that has evolved to bring that context in automatically, and literally with one click, we still have the human in the loop, right? We're not automatically executing these remediations. The human can still review the hypothesis, the suggested remediation, but with one click, you can actually go ahead and execute the remediation, and it'll make the changes to your environment. The third agent I want to talk about briefly is the optimize agent. This time, I will not ask a rhetorical question because I know what the answer is going to be. Now, you all probably are surprised from time to time about cost spikes, right? It could be because somebody is running some rogue application, maybe the workload has gone up, which is a good thing for your business, or maybe somebody's deployed agents, and the agents are doing a lot of reasoning and chewing up a lot of tokens. These cost anomalies can obviously be challenging for the business, and the other related challenge is when your FinOps teams look at their cost dashboards and come ask the DevOps or the IT Ops teams about, hey, we're seeing a cost spike, what could be going on? Most of the time, the response from IT is, well, here's our metric dashboard, you figure out why the cost is going up. So there is a clear gap between the conversation the two teams are having. The optimize agent will literally act as your personal assistant to analyze cost information. You can ask it questions, why is my cost going up? Which resource is utilizing a lot more, is heavily utilized? And you will get appropriate answers from that analysis. It will also do cost to change correlation. So if your environment has changed, if you have changed the configuration, if you've deployed a new application, that information is fed into the cost analysis, and the cost analyzer can actually tell you these are most likely the changes that have caused costs to spike, pardon me. And like I said on the previous slide, this can also be activated proactively. So you can define cost-based alerts, and the system will continuously be analyzing the cost information, identify anomalies, and once it has identified anomalies, do the correlation to the resource usage and be able to tell you what could potentially be causing the cost spike. All right, so like I said, we've introduced these 3 agents. There are other agents for testing and documentation, et cetera. Let me just briefly touch upon why we're doing this and what's in it for you. So the first thing is, it's the focus on the complete SDLC. Like I said, it's not just about coding. Coding is critical. Without code, you have nothing to worry about. But once you have written the code, once you've accelerated the speed and productivity of building code, you have to make sure that this code makes it to production and it continues to stay up and running. And so we have introduced agents for the entire SDLC. Inner loop, outer loop, the whole thing. The second part is the full stack integration. And again, if you attended the keynote yesterday, Thomas talked about the AI stack. And when the AI stack, what he was talking about was from the hypercomputer to the models to the agents. That is certainly true, but we also have all of these agents, whether they're the coding agents or they're operational agents, they are part of the GCP platform, right? They work with the same identity systems. They work with the same registries. They work with the same gateways. And as a result, whether you're a developer or an operator, you get a pretty comprehensive experience with the same underlying services that actually support building and deploying these agents. And last but not least, the value of these things. These things are packaged and priced into a single SKU that you purchase, and it has predictable pricing, and you have very high, practically no limits today for usage. And the design agents, all these other agents, they're using tokens, but you're purchasing them in a SKU that is subscription-based. So with that, I would like to invite Sachin on board to talk about how they have used all of these capabilities at Wipro to automate and improve their environments. Sachin.
Good morning, everyone. Am I audible? Yeah. So I'm Sachin Chandra, the global practice head for Google Cloud in Wipro Technologies. Thanks to Rakesh and Alok, I can proudly tell that we are a customer for Gemini Code Assist, and most of the use cases what Rakesh and Alok explained here, we have seen them in action. Okay, but I want to talk about one specific challenge what we have faced while we started adopting GCA in Wipro and how we have handled it. When we have taken Gemini Code Assistant licenses for our developer community within Wipro, the adoption we have seen that it's very flat in initial few months. It was not even touching 100. Then we did an analysis and we could find that where is the mind block, right? Because Wipro already had many other platforms available for usage. And you all know any new platform comes to market or for you to consume. The question is that why a new tool? What is that I'm going to get? Why should I put effort in learning a new tool and taking effort to integrate that? And definitely there is a lot of onboarding challenges, adoption, mind share. So that is where we have taken a structured approach to handle this. And that approach is around mindset, skill set, and tool set. The mindset is about how do we build the mind share with the developer community. For that, what is the first to identify who will benefit the most by using Gemini Code Assist? In Wipro, we have picked up a set of audience or developer community working with customers on Google Cloud technologies or Google Cloud migration. We have picked up them as a pilot group. The second part was about how do we build that mind share. So we conducted multiple ideathon, hackathon with the help of Google, and it was a very interactive session. It was not a classroom sessions. We co-built solutions in the room itself, right? We have built around 150 plus agents, and to our surprise, some of the developers came out with great ideas and built a lot of new themes in the sessions. We conducted around 40 plus in-person enablement session across the globe and multiple ideathon and hackathon. So in the skill set, so this is about the mindset. Skill set, we also onboarded a very specific Gemini Code Assist related best practices, SOPs. We created a community, and the people who had really seen the benefit, they had been giving the examples of where it has worked well. Now I'll come to the tool set. This is very interesting, right? While we have seen and used it for the standard software development life cycle, and we have seen most of the metrics aligned to the industry standards. We use this for platform development. We use this for some of the key customer development, for SDLC. We have used for some of the SAP modernization use case. We have seen that it's working very well. But we did not want to limit GCA to just to the code productivity. We want to take this to and play to the strength of Gemini. And it is, for us, adoption of GCA is not just the productivity improvement, but reimagination of developer experience. And to that, we wanted to play to the strength of GCA. And one thing what we have seen is that GCA works very well in CLI, very well with Gemini in services within Google Cloud, like Gemini in BigQuery, Gemini Cloud Assist kind of technologies. We have really seen the power of GCA. And I'll take you to some of the use cases where we have really used this. We have used this extensively for cloud operations. Take an example like an SRE, like your GKE clusters are breaking because of some RBAC security issues or access issue. In a typical way, it takes hours for us to really understand the root cause and come out with the remediation. By using Gemini Cloud Assist and CLI, we could actually bring that effort to minutes. And any kind of a security incident, say for example, you have seen some kind of a cyber threat, somebody is trying to, some suspicious activity in your environment, the entire root cause analysis and investigation by using CLI and a combination of Gemini Cloud Assist, we have seen it working very well. So by taking the power of CLI, Gemini in the Google services, we could actually take the assisted productivity to an agentic workflow. That is the transformation we have seen, and I'll show you the outcome, right? The outcome talks all, and you can see that first few months, the adoption was very flat, and it really gone multifolded in few weeks to months. And so to summarize, it is about identification of the right set of people who will get the maximum benefit of GCA, identifying the right use cases. Yes, the standard productivity is there. It has been there with multiple products, but there are certain unique power of GCA playing to that, and with the continuous learning and evolving that with the help of Google had really helped in maximizing the adoption for us.
you.